Hello everyone, I am Dr. Sirajul Faisi. I welcome you in my YouTube channel. Today in this video, I am going to discuss about oxidation state in alkenes. So let us start learning of oxidation state in alkene. You can see this molecule is known as ethylene, and there are two carbon and both carbon attached with the double bond, but this carbon contains these two hydrogen, so oxidation state of this carbon is -2. In another carbon is also -2. You can see in this example this carbon attached with the carbon and hydrogen, so oxidation state of this carbon is -1 and this carbon -2. Now you can see this molecule, this carbon attached with the one hydrogen and this carbon also attached with one hydrogen, so this both carbon oxidation state is -1 and -1. Now this alkene, this carbon attached with the carbon and attached with the carbon, so the oxidation state of this carbon in case of this 0 and in this case -2. Again this carbon oxidation state is 0 and this carbon is -1, and here this is the mistake in book. So this carbon and this carbon, this is not hydrogen, this is the carbon, so this carbon is attached with the carbon and carbon, so oxidation state of both carbon is 0. So several carbon oxidation level are again possible. Both carbon atom must be considered as a part of the same alkene function group, while the total oxidation level can go from -4 for ethylene as the sum of the oxidation level of both carbon atom in the function group, and to 0 for tetrasubstituted alkene. So all are of the same functional class. So combine because carbon double bonds, you have to take this oxidation state in combined form. Furthermore, it is evident that because the lowest possible oxidation level of a single carbon atom in alkene is -2, while the lowest possible oxidation level of carbon atom in an alkane is -4, so alkene are thus oxidized relative to alkanes. So this is also very important to know that alkane is oxidized form or alkene is oxidized form. So alkane is -4, so alkene are thus oxidized related to alkane. Now you can see the oxidation state in common functional groups like alkyne. This carbon is -1 and this carbon is also -1. Why? Because this carbon attached with this hydrogen and this hydrogen. In alcohol, you can see this carbon is -1. Why? Because this one is attached with the oxygens. And aldehyde and ketone, this carbon is -2 here, and this is +2 and -2, so oxidation state in case of formaldehyde, carbon oxidation state is 0. Here also -2 and carbon has the +2, and then we introduce hydrogens -2, so 1 is cancelled out, -1 is remaining. In this formic acid, you can see the oxidation state of carbon is +2. Why? Because here -2 and +2, here +1 and -1, here -1 and +1, so +1 and +1 +2. In the same way, this carbon attached with the so oxidation state 0, 1 hydrogens, so -1. In this case also oxidation state is 0, because this is the 1 minus 1 and these two, this plus 1, so 0 oxidation state in this alcohol. And in aldehyde you can see the oxidation state due to this hydrogens and oxygens, so -2 plus 2 and -1, so +1 is remaining. In the same way, this substituted oxidation state 0 0, third alcohols +1, in this case -2, so +2. Here RCOOH due to +2, -2, +2 and -1, so oxidation state of carbon in case of carboxylic acid RCOOH, 3 oxidation state. So my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.